Hi, I'm Belinda, and welcome to my learning project about supporting first year college students in introductory biology courses with technology based projects. So, first up is our context, including our goal. So, overall, at Trident Technical College, our department needs to improve student scores on formal assessments for the topic of DNA replication, transcription, and translation. Our learning objectives state that students should be able to describe those three processes in detail, and we found that students are not mastering that level of comprehension. And previous versions of this lesson were much more instructivism based with a teacher lecture, and students had no opportunity to really explore these processes. This year, we've updated our lessons to incorporate a group project, and we want to continue to do group projects, but only if they're meeting our goal to improve those test scores. Additionally, any changes that we make to these lessons um, need to support and prepare students for future biology work, whether that is at their four-year college they transfer to, their nursing or health science program, or they graduate and go into their career after Trident Tech. So who are we taking a look at? I'm looking at first year college students. In an introduction assignment provided to students, 73% of my class identified themselves as first year college students. And diversity, as I've defined it in this project, includes our social networks and how we organize ourselves and approach problems. And I found through my research that will be presented later that first year college students have unique needs in those social networks and their engagement with the world. And so they became the focus of this study. Where are they going to work? Our group project will take place at the Thornley Trident Technical College campus in North Charleston. Students come from Berkeley, Dorchester, and Charleston counties. They're in the 630 building, which is our health science building, in room 222. This is a typical biology lab with safety equipment and sinks and gas valves and lab tables. And students were also allowed to work in the hall if they needed a little more room for their project. So what were these students doing? We created this project where students would make a stop motion video of one of the three important processes of DNA replication, transcription, or translation. They would use the Stop Motion Studio app, or as you saw in that very short clip, some of them used a different app called CapCut. They spent one class period learning about the processes and becoming familiar with the app. The second class period, they got into groups of 2 to 4 students, planned and filmed their video. Then we viewed the videos and students provided their peers with feedback on the processes they did not record. So our first research article is talking about first year requirements in order to retain students. And what we found is that Mayo suggests that students who are first year students need additional support in creating relationships, even if they come to school with pre-existing connections to maybe their high school friends. They also need help with things like time management and study skills. And he argues that schools should have a freshman seminar course. However, Trident Technical College does not have that. So Mayo suggests faculty, advisors, and staff can incorporate those study skills and time management and relationship building into their classrooms. And this group project was able to allow for that time management, that introduction to technology, and those connections to new people in their school community. In our second article, Super et al. Reflects on how using reflections in Biology 101 topics in an online course promoted more inclusion for these first year students. At first, this study was really talking about how there was internet and technology inequities during the online school era of the COVID-19 pandemic. But what they found is that students were more engaged with material when they did these reflections. And at first, students required scaffolding to make sure that they were providing good reflections, but over time, they were able to do these reflections on their own. And it was an important part of creating a social group as well as a social cognitive group where learners could challenge ideas with one another. And in my group project, there was a peer feedback process that allowed for this engagement among the different groups and bouncing those ideas off each other. Then our third article is by Wang, which is where there was a literature review of first-year community college students in science, technology, engineering, and math fields. And we found that this was a vital stepping stone for students who, for a magnitude of reasons, did not start at a four-year school, and that student self-efficacy, or the feeling that they could be successful in their STEM courses, as well as positive interactions with their peer group and faculty, and relevancy to the curriculum was important for success now and in the future. And in our Trident Tech Group project, students hopefully had a positive interaction with peers and me as their faculty member, as well as they were able to reflect on their work and the work of others. And then by using this app that they could use outside of the classroom, hopefully they also felt like there was some relevancy and fun in this project. So then how does this all relate to the theories we've seen? Well, universal learning design is this framework that gives us multiple means of engagement, representation, and action and expression. And under that action and expression principle, we have guidelines and checkpoints that support goal setting and planning and using different media and tools. Super et al. And Mayo's article both talk about the importance of reflecting and different communication and reaching these first year college students. And again, within our lesson, students were given choices of the process to represent, of their group, of how they could represent the process with Play-Doh or dry erase or other models. They had planning documents, and they could then, of course, do their peer reviews in different media. Next is constructivism, which is where a learner builds knowledge within a schema they create. And this is a very active process where the instructor is a facilitator. All three articles emphasize the importance of first-year college students working within small groups to build their knowledge, to build and reflect on their relationships and experiences. And by utilizing this small group project, students were able to challenge any ideas they had about these processes. They constructed a physical model, and they got to work with their peers to create these movies. And future considerations could be going towards a problem-based case study where students also construct their problem that they want to solve. Then, of course, we've got behaviorism with social cognitive theory, which is that our thoughts, behaviors, and environment are all keys to learning. And of course, we saw with Wang et al. That self-efficacy is vital for students' success in STEM courses. And within our group project, students first were able to observe a video and then imitate that. They saw a different biological process, mitosis, to model. They could also see what other students were doing within our classroom in order to, build what they were making. And of course, in the future, perhaps having students who are more proficient in the content or the app become that more knowledgeable other to bounce those ideas from. All right, and here are my references. Thank you for watching, and I look forward to your feedback.